We are looking at Unit 2 review in preparation for your Unit 2 assessment. Number 1 and number 2 have the directions to write an equation of the line given the following information. We will write the equation of the line in the form y equals mx plus b, where m is the slope and b is the y-intercept. Going from one point to the next, 1, 1 to 2, 3, we go up 2 and right 1. So the slope for this given line is 2 over 1, or just 2. The y-intercept is at -1. So now the equation that goes with this line would be y equals 2 for the slope, x, minus 1 for the y-intercept. On number 2, you have the points 9, 1, and 6, 4. Label those x1, y1, and x2, y2. We need to find the slope first between the 2 points. So we would have 4 minus 1 over 6 minus 9. That would give us 3 over -3, which is equal to -1. You then can use the point slope formula. Y minus y1 equals m parentheses x minus x1. We can fill in the y1 with +1 from above. We can fill in -1 for the slope. X minus and x1 is 9. Distribute the -1 to the x and the -9. Y minus 1 equals -1x plus 9. Add the 1 to both sides. We should get y equals -1x plus 10. Same directions to write the equation of the line. With number 3, we have a slope of 0 and passing through the point 7, -8. Go back to y equals mx plus b. The m is given to us to be 0. The y would be -8. And 7 would be x. And bring down the plus b. 0 times 7 is 0, leaving you just the plus b, or b. So here we have -8 equals b. We will fill in the 0 again for the m, and fill in the -8 for b. And to simplify, 0 times x is 0, so you're just left with y equals -8. Number 4, a vertical line passing through the point 1, 2. A vertical line is x equals a number. In this case, you're just looking at the x value given here because that would be the only part of that point that refers to the vertical line. X equals +1. Number 5, you've got an m, an x, and a y. So if I go to fill in for y equals mx plus b, I have -3 equals 1 over 3 for the m times -6 for the x plus b. -3 equals 1/3 times -6 is -2 plus b. Add 2 to both sides. We get -1 equals b. So our equation of the line, y equals the 1/3 for the m they gave us, x minus 1 for the y-intercept we just found. Number 6. Parallel to y equals 5. If I expand this out, y equals 0x plus 5 is what I would have. As 0 times x is 0, and 0 plus 5 gets me back to y equals 5. Parallel tells me to keep this slope the same. So m is going to be equal to 0. Here is an x, here is a y. For us, we plug in 1 for the y, we plug in 0 for the m, we plug in negative 3 for x, plus b. 0 times negative 3 is 0. Add that to b, you just get b. So 1 equals b. And again, I'm plugging into y equals mx plus b. Plugging in the m and the b, I get y equals 0x plus 1, or just y equals 1. Number 7, perpendicular to y equals 1 over 2x minus 6, passing through the point negative 4, 9. For this problem, identify what the slope is of this original equation. It is 1 over 2. We're looking at a line perpendicular to that. So we flip, we get 2 over 1. It was positive, we have to change the sign. So negative 2 over 1 is just negative 2 for the slope. I'm going to plug in negative 4 for x, 9 for y, and y equals mx plus b. Solve for b, and then write out my equation. 9 in for y equals negative 2 for the slope times negative 4 for the x plus b. 9 equals positive 8 from the negative 2 times negative 4 plus b. Subtract 8 on both sides. I get that 1 equals b. So for filling in y equals mx plus b, I have that y equals negative 2 for the slope, x plus 1 for the b. The next set of problems ask you to sketch the graph. Number 8 has x equals negative 3. Anytime you have x equals, the graph will look exactly like this, where there is no y, only x and a number. So negative 3 is right here. If I graph this line, it's going to go completely straight up and down, keeping on the grid as best as possible, as that makes the point negative 3, 0, negative 3, 1, negative 3, 2. X will always be negative 3, and the y's can be any value you want. For number 9, y equals graphs where there is no x present will be a completely flat horizontal line. Here, 5 is on the y-axis. It's also the y-intercept for this. It has a slope of 0, so it is completely flat horizontally, going to the left and to the right with arrows on either end. When you have the x and the y present, remember y equals mx plus b, where here m would be 3 over 1, b would be negative 5. I'm going to plot b down here at negative 5 on the y-intercept. From there, I go up 3, 1, 2, 3, right 1, up 1, 2, 3, right 1, up 1, 2, 3, right 1, and then I'm going to do my best to connect this to make a straight line, although I know it's going to be kind of rough since I'm drawing this using a tablet. On the next set of problems, we're asked to solve. Number 11 says 20t minus 25 equals 5t plus 2. I'm going to move the 5t to the other side. It was positive, so when I go to move it, I'm going to make it negative, or subtracting it. These 5t's cancel. I bring down 15t minus 25 equals 2. I'm going to add the 25 since it was negative or subtracting originally. The negative and the positive 25 add to give me 0, so I cross them out. 15t equals 27 from the 2 plus 25. I'm going to divide by 15 on both sides. I get that t equals 27 over 15. However, I know that 3 goes into 27 9 times. 3 goes into 15 5 times. So for our lowest term there, t is 9 over 5. Number 12, we have the fraction 2x plus 3 over 5, adding the quantity x minus 3 over 2 equals 5. What I'm going to do is multiply each fraction here by 1 in the form of a fraction. We have a 5, we have a 2. I'm going to multiply this one by 2 over 2, this fraction by 5 over 5. And I'm doing this so that these will have the same denominators. This will have a denominator of 10, and the second fraction will have a denominator of 10. This is 2 multiplying 2x plus 3, and this is 5 multiplying x minus 3. I'm going to write that out. I'm going to go ahead and take care of this distribution. 2 times 2x is 4x. 2 times 3 is 6. This is positive 5 times x, which is 5x. This is positive 5 times negative 3, which is negative 15. I'm also going to write this whole thing as over 10 because I'm writing these all together under one fraction. And the whole thing still equals 5. 9x is what we'll have from adding 4x and 5x. 6 minus 15 gives me negative 9, and it's still over 10, and it equals 5. I'm going to multiply by 10 on both sides to get rid of this 10 on the bottom. This 10 and this 10 cancel. I'm now left with 9x minus 9 equals the product of 5 and 10, which is 50. I'm going to now add the 9 to the other side. I'm left with 9x equals 59 from 50 plus 9. Divide by 9, and I have the problem that x equals 59 over 9. However, I want to check to see if that fraction will reduce any further. And it does not after I type that in my calculator. It would be advised that you would plug in these back to the x's in the original problem to make sure that they do equal the 5 on the right, or give you a true statement over there on number 11. Number 13, negative 3x plus 10 greater than negative 2x minus 4. What I'm going to do is move this 2x to the other side. It was negative, so I'm going to add it. The x's will cancel on the right, and you're just left with a negative 4. Over here, negative 3x plus 2x is negative 1x plus 10 is greater than negative 4. I'm not going to move the 10 to the other side. It was adding, so I'm going to move it with subtraction. using an inverse operation. Negative 1x is greater than negative 14. I divide by negative 1. Remember, when I do that, I will flip the direction of the inequality. Negative over negative is positive, so I've got positive 14. On a number line, I have positive 14. Notice that this inequality symbol looks like this in the arrow, so I would shade in this direction. And it does not have the equals to, so it would be a parenthesis. So the shading represents negative infinity with a parenthesis, comma 14, our answer, with a parenthesis. Number 14 asks you to go through and solve for x, and then graph and give interval notation, like we did over here on the left. I'm going to start this off by adding the 5 to all sides. When I do that, negative 8 plus 5 is negative 3. Less than negative 2x, the 5's cancel in the middle, less than or equal to 13. I'm going to divide by the negative 2, that coefficient of the x. The negative 2's cancel in the middle, so I drop down the x. I divided by negatives, so this inequality symbol and this inequality symbol flip. Negative 3 over 2 with a negative in the bottom as well leaves me with just positive 3 over 2. And over here, I have one negative and then 13 over 2. Notice that with inequalities like this, we need the negative on the far left and the positive on the right. So I'm going to write this negative 3 over 2, our x, and our 3 over 2 in the correct order. Notice that the negative 13 over 2 had the inequality facing away from it. So we want to maintain that with the equals to. The 3 over 2 has inequality opening up towards it, so we want to maintain that. Now, if I go to make a number line, I'm going to jot down the negative 13 over 2 and the 3 over 2. With the 3 over 2, I know it's going to be a parenthesis, and I know I'm going to shade in this direction because this inequality symbol looks like that in the arrow. So I'm going to shade that way. With the negative 13 over 2, I need the variable on the left side to be able to know which way to shade. So I have to rewrite it so the x is on the left, and I have to flip this inequality symbol when I do that. Notice it will then shade this way. So these two will shade in the middle. And this has the equal to, so it gets the bracket. So we get a bracket, negative 13 over 2, comma, 3 over 2 with a parenthesis.